Hi and welcome to this 2019 paper walkthrough or question tutorial on BMAT section 2. So here's our first question. It's a typical genetic engineering question and we're going to go through it through a process of elimination. So our first column is asking us about W. I can see that it is a section of my chromosome, so I know that it's a gene. So immediately I'm going to be able to eliminate A, B, C, and D from my options. Then let's move on to X. X features twice here, and we've got those lightning symbols, and I can see that every time we use X, something is removed, so a section. So it's cutting. So this is going to be a restriction enzyme. It's going to cut between two areas. So I'm going to get rid of options F, because that said ligase, and H. And then finally, we've got looking at Y, and this is the only one that's differentiated between, because Z is both ligase, so this is going to be our one that tells us what our correct answer is. So here with Y, I can see I've got a circular unit here. Now that is going to be a plasmid. A plasmid is a circular piece of bacterium, and we're cutting a bit away from it. So I can tell it's not the bacterium itself, it's found within the bacterium. So I'm going to get rid of G. So E is my answer. Our second question. The first thing I'm going to notice here is that I've got a metal carbonate. So when I react that with a cleaning solution, then I'm going to have carbon dioxide being formed. So I can write this as a general equation in the corner to help me with this question. So metal carbonate plus an acid is going to be a metal salt. And of course, it's going to be carbon dioxide. CO2 is going to be made. So I can see here that statement 1, the cleaning solution is acidic. That is going to be correct. Okay, it's going to be fizzing, so it's going to be acidic. Statement 2, the effervescence is caused by the release of hydrogen gas. I'm going to tick that as correct so I remember. No, we've just agreed that we are making carbon dioxide in these reactions. So that statement is incorrect, it's false. Statement C, the pH of the reacting solution will go down as the reaction proceeds. Well, it's a neutralization reaction. We've got our calcium carbonate, it's a base, so it's alkaline, so we're going to have a high pH. The cleaning solution is acidic, so it's going to be bringing that towards neutral. So because of the presence of the base, the pH was high at the start and then it's going to lower. So we've got option 3 as being incorrect, and then statement 4, the salt produced in the reaction is more soluble than calcium carbonate. Well, the information tells us that the lime scale breaks down. It's not there anymore. So we can tell that at the end of the reaction, it disappears. Therefore, it's going to be more soluble than the calcium carbonate, which was solid at the start. So that statement is correct. So we can see that 1 and 4 are correct. So our answer is C. Question 3. For this question, mass and the acceleration is going to be really useful for us. So we can use the formula F equals ma, so force equals mass times acceleration, to work out one of our really important, or the resultant force of our cyclist. Remember that resultant force, then we can say that that is equal to overall over net force. Okay, so let's do our force first. So F is equal to, in this case, or our resultant force is equal to the 50 kilograms of the cyclist times the 4 meters per second that they're traveling. So that is 200 newtons. So 200 newtons, okay? So taking the direction of the cyclist as positive, we can then set up an equation where we've got the force the cyclist produces, or the forward force produced by the cyclist in the bicycle, which is 600 newtons, minus the resistive forces acting against the cyclist in the bicycle, which is 300 newtons, minus the air resistance, which we don't know, is equal to what we've just worked out, 200 newtons. Therefore, solving that equation for the unknown, for air resistance, we can see that air resistance, I'll just shorten it to air R, is 100 newtons. So our answer is B. Question 4. The first thing we're going to do here is simplify this equation. Okay, so we can say that P plus Q is equal to 3P minus Q. And that can be written as P plus Q is equal to 3p minus 3q if we expand those brackets. This can then be rearranged to 4q equals 2p. Both sides can then be divided by 2, and of course we're going to get 2q is equal to p. We can then substitute the expression p equals 2q into the equation of the question that is asking us to solve. So every time p appears in the equation, we can simply replace this with 2q, and that's going to enable us to solve it. So our numerator, for example, is going to be 2q times q is equal to 2q squared. Of course, our denominator is going to be 2q squared plus q squared. So that is equal to 4q squared plus q squared, and that is, of course, 5q squared. So putting this all together, we've got 2q squared divided by 5q squared. And of course, that can just be simplified to 2 over 5. So my answer is B. Question 5. So this question tells us that the shaded areas are for processes that do not require energy. So they don't require ATP. So I'm going to quickly summarise what I know about what requires ATP and what doesn't. So I know that requires ATP or does not, or maybe I'll just put no ATP. From what I've learnt so far, of course, active transport and aerobic respiration require ATP. No ATP, we've got diffusion and osmosis. So that's going to help us summarising there. Area 1 is unshaded, so we know that this process does require ATP. It's an active area. So it means that active transport and aerobic respiration are the only processes that can be in Area 1. And that immediately means I can eliminate C, D, and E. So let's get rid of those. Areas 2 and 3 are shaded, so we know that those areas do not require ATP. So that means that Area 2 can only be diffusion and or osmosis. So from this we can eliminate B, F and G. Therefore, we can see that A is our answer. Question 6. During electrolysis, our positive ions are going to move towards the cathode because the cathode is negatively charged. Of course, opposites attract. And it's going to get reduced. So that makes me think of oil rig. If it's reduced, it means it gains electrons. So the question states that the chemist wants to electroplate a copper rod with a layer of silver. So this means that silver is being deposited on the copper rod. Therefore, one of the half equations has to be, for example, my silver plus E minus is going to give me my solid silver being deposited. This is a reduction reaction, so we know it's going to be happening at the cathode because of reasons we just talked about. So this suggests that the cathode is going to be made of copper. Therefore, we can eliminate options B, C, and E. The positive silver ions must therefore be coming from the anode, which is made of silver. Therefore, the anode, we're having an oxidation reaction, so they are losing electrons. Therefore, my equation there will be Ag, gives us my ion and my electron. And I'm therefore, because I know it has to be a silver rod, I can eliminate F from those options as well. So now we're down to A and D, and they're only differentiated by the electrolyte here. So we know that in electroplating, the electrolyte should be an aqueous solution consisting of the coating metal. Therefore, the electrolyte should be, in this case, silver nitrate solution. So that makes our option, the correct option, D. Question 7. A key thing to remember is that our formula for density is going to be the mass of an object divided by its volume. So let's find those pieces of information. So we can calculate the mass of object X by, of course, subtracting our values on the mass balance. So our mass of X will be our 950 minus 750 grams. So our mass is 200 grams. And then we can find our volume in a similar way. So we can subtract our volumes that have been displaced. And it specifically says that no liquid was lost from our cylinders. So if we are going to subtract our volumes, 500 centimeters cubed of diagram 2 minus the 375 centimeters cubed in diagram 1 is 125 centimeters cubed. So inputting those into the density formula, we are going to have our mass of 200 grams divided by our volume of object X, 125 centimeters cubed, and that's going to give us an answer of 1.6 grams per centimeter cubed. So our answer is C. Question 8. The first thing to do here is to get rid of the standard form and write out the fraction as it is. So I'll write 600, so my first 6 times 10 to the 2, plus 40 divided by 0.012 plus 0.004. And then I can shorten this further. It's going to be 640 divided by 0.016. After this, rewrite the fraction in terms of square numbers, because of course these can be easily square rooted. Remember that square rooting fractions means multiplying each of the indices by half. The fraction can then be simplified. So let's give it a go. So 640 is 64 times 10, and 0.016 is 16, our square number, times 10 to the minus 3. So I can continue to work on this. So I can square root my top. It's going to be 8, square root is 64, times 10 to the half. Because remember I said an indices, square rooting it is to the power of half, divided by square root of 16 is 4, times 10 to the minus 3 over 2. So I'm putting that to the minus 3, halved it. So that's going to be equal to 2 times 10 squared. Because, remember, when dividing indices, you're just going to subtract the indices from one another. So half minus 3 over 2 is 2, as we've got it up here. So finally, 2 times 10 squared is 200. So you've taken quite a tricky equation and worked out that the answer is E. So question 9. Statement 1. We're being asked, the respiration rate of the lizard is inversely proportional to the environmental temperature. Well, I'm going to put an arrow down because I can see that my temperature, as we go along, is decreasing. So, or I'm going to take it as when the temperature is decreasing, what is happening to my rate of respiration? Well, the amount of carbon dioxide that I'm producing is also decreasing, which is suggesting that as the temperature decreases, my rate of respiration is also decreasing because less carbon dioxide is being made. That means that I've got a directly proportional relationship between the two, not an inversely. If it was inverse, we'd have one decreasing while the other one is increasing. So that statement 1 is incorrect. Statement 2, the data demonstrates that the lizard is only expiring aerobically. I do not have enough information to confirm or deny that statement. We're not given enough detail about it. So again, I cannot say that statement is correct. And finally, the carbon dioxide could be detected by passing air leaving the chamber through lime water. Yeah, it can. That statement is correct. That is a way of testing carbon dioxide presence. So I can see that only one of them is correct. So, and it's statement 3. So D is my correct answer. Question 10. This first statement here, it has the most vigorous reaction with cold water. This is fairly logical. As we move down group 1, the one electron in the outermost, the highest energy shell, is going to get further and further from the nucleus as we move down. We've got more shielding going on. So it's going to be easier and easier to lose that outermost electron. So as we go down the group, we are going to get a more rigorous reaction with cold water. So that statement is correct. Statement 2. its atom has the same number of electrons in its highest occupied energy cell. Yes, it's got one. All of the elements in group 1 have got one electron in the highest occupied energy level. That's why they're in group 1. And statement 3, it is the most readily oxidized. This is also true for the same reasons as I discussed for statement 1. Okay, it is the easiest to lose that electron from the outermost shell. Remember oil rig? Oxidation is loss of electrons. So it's easiest as we move down the group to lose the outermost electron because of the shielding and the size and the radius. So we can see that all 3 of these statements are correct. So the answer is H. Question 11. So this statement tells us that the larger sphere is negatively charged. That's telling us that there must be less protons in relation to the number of electrons. Therefore, immediately I can eliminate D, E, and F because there must be less protons to have that overall negative charge. As electrons in the smaller sphere are repelled by the electrons in the larger sphere, and they're going to flow to Earth, we can state that the smaller sphere loses electrons. This will give it an overall positive charge. Therefore, due to that elimination, we can see the correct answer is C. Question 12. The first thing I'm going to do here is write out the general equation to work out a gradient. So to work out a gradient, y2 minus y1 over x2 minus x1. To make it a little bit easier for myself, I can annotate up at the top here what I'm dealing with. Therefore, substituting those values in would give me my y2 value is 2 minus my y1 value, which is 3p minus 1, over my x2 value, which is 1 minus p, minus my x1 value, which is 6. I can say that this is equal to minus 3 because of the statement here. We've been told that. Let's expand this information then. So then I can also say that 3 minus 3p over minus 5 minus p, having expanded all these brackets up here, is equal to minus 3. And then I can keep going on this expansion. I can times out both sides by minus 5p. And if I do that, I will get 3 minus 3p is equal to 15 plus 3p. Therefore, I can say that 6p is equal to 12 and p is equal to minus 2. So now I've worked out p, this is going to be really, really useful. The point R is the y-intercept of the straight line. So using the format y equals mx plus c, I can create an equation for that line. So y is equal to minus 3x, because I've been given the gradient as minus 3, plus r, because that's the intercept. We can now put the actual coordinates for m into this equation to work out r. So, having worked out that p is minus 2, we can say that the coordinates for m is 6, 3p minus 1. So 3 times minus 2 is minus 6 minus 1. So that has to be minus 7. You can see we've got that information up here. Therefore, we can plug in our values for that equation. So we can say that y, which is minus 7, which we've just worked out, is equal to minus 18 plus r. Therefore, our value of r has to be 11. So our answer is H. Question 13. So this is quite a quick question. Our amino acids, cellulose and lipids all contain carbon atoms. Therefore, they are all involved in the carbon cycle. So our answer is H. Question 14. Be careful with this. Don't fall into a trap. Circle which curve they want you to be talking about. So they're asking about curve Y. not x. So we're looking at curve x and we're comparing y to it. What I'm focusing on here is the initial gradient, the initial rate of reaction. And I've got a much steeper gradient going on here than I do for x. Therefore, I can immediately tell that my magnesium oxide, in terms of particle size, is going to be powdered. It's going to increase that surface area available for the reaction to take place. So the reaction is going to take place faster. The rate's going to increase. That allows me to get rid of D, because that said granulated, and E. So now I'm considering the volume of hydrogen peroxide. So I can see that Y levels off earlier than X, so it's going to be a lower amount. And I'm going to actually count how many squares. So X produces 1, 2, 3, 4, 5 squares of my gas, whereas Y produces 1, 2, 3, 4. So it produces 4/5 of the amount of gas. So using the equation, moles equals concentration times volume. The number of moles used of hydrogen peroxide in the reaction was therefore 0.1 decimeters cubed. So the number of moles of hydrogen peroxide used in the reaction was 0.1 moles per decimeter cubed, that's my concentration, times my volume, which I need to convert to decimeters cubed. So 50 divided by 1,000. And that equals 0.005 moles. Therefore, 4/5 of 0.005 is, of course, 0.004. I then want to check in my diagram which one, A, B, or C, has two figures that multiply to give me 0.04. So, volume of hydrogen peroxide, 0.002, which is 20 centimeters cubed, converted to decimeters cubed, times 0.2 is 0.004. Therefore, I know that my correct answer is A. Question 15. We're being asked which of these statements is correct. Let's start with statement 1. All longitudinal waves travel at the same speed. That is incorrect. They can travel at different speeds. Statement 2. Longitudinal waves cause vibrations perpendicular. That is also incorrect. That is the definition for transverse waves. Sound waves are transverse. They're not. They are longitudinal. Transverse waves always travel faster than longitudinal waves. Again, that's also incorrect. Under certain conditions, longitudinal waves may travel faster than transverse waves. Transverse waves are all electromagnetic. That's not the case. So electromagnetic waves are transverse waves, but that doesn't mean that all transverse waves are electromagnetic. Ultrasonic waves are longitudinal. That is correct. So only one of these statements is correct, so we know that F is correct, but I'm just going to check the next two. Ultraviolet waves consist of compressions and rarefractions. That one is also incorrect because they're transverse. They're not longitudinal, and that's what we would get with longitudinal waves. And finally, X-rays cannot travel in a vacuum. It's incorrect. They can travel in a vacuum. All waves in the electromagnetic spectrum can travel in a vacuum. They don't require matter. So, yeah, our answer is F. Question 16. The first thing I'm going to do is draw a quick sketch of what this rectangle might look like. So I've got one length, which is X, I'm trying to find out, and then I've got one side, so I'll put that in. Square root of 5 centimetres. The area of this rectangle is 66 centimetres squared, so I can create the formula X times 7 minus root 5 is equal to 66. Let's rearrange to make X the subject. So X is equal to 66 divided by 7 minus root 5. Because we have a surd as the denominator, I need to rationalise this fraction. So I'm going to times everything by 7 plus root 5. So if I times everything by 7 plus root 5, I will of course get X is equal to 66 7 plus root 5 over 49 minus 5. And we can also say that that is equal to 66, 7 plus root 5 over 44. I can see that both of these are divisible by 22. 66 and 44 are these two numbers here. So I'm going to divide it by 22. So X is equal to 3, 7 plus root 5 over 2. And finally, I'm going to expand that bracket. So it's equal to 21 plus 3 root 5 over 2. Next, let's work out the perimeter of the triangle. So we can write the perimeter as 2x plus 2 times 7 minus root 5. Earlier on, we worked out the value of x. We've got it here. And it's great because we've got a 2 as the denominator. So we can also say that 2x is equal to 21 plus 3 root 5. And I can plug that into my perimeter equation. Therefore, my perimeter is 21 plus 3 root 5 plus 14 minus 2 root 5. This can be simplified to 35 plus root 5. Hence the answer is D. Now, there are a lot of calculations involved in this. So note that if you find that you've been looking at this question for over a minute and a half and you're not hearing that answer, do feel free to guess the answer and move on. Question 17. We've been told that this pea plant is heterozygous for seed colour. And we've been told that we've got 2 potential alleles. We've got a capital Y for yellow seed colour and we've got a lowercase y. So I know that my seed could have either big Y or little y. And then it tells us that we're homozygous for seed shape. So I can only have either capital R or lowercase r. So I could have capital R or lowercase r. It's homozygous, they both have to be the same. Let's go through our options then and see which we can have. This plant contains the alleles capital Y, lowercase y, capital R, lowercase y. That cannot be true. Like I said, we can only have capital R or both lowercase r's because it's homozygous. So statement 1 is incorrect. The plant contains both the different alleles for Y and capital R. So yes, that could be correct. The plant contains only the alleles here. Well, no, we haven't got lowercase y included. So that cannot be correct. The gene type of this plant for seed colour is capital Y, lowercase. Absolutely, because we know it's heterozygous. It cannot be capital Y. That would be homozygous. So that statement's incorrect. For seed shape, capital R, lowercase r, that's heterozygous, but we've been told it's homozygous for seed shape. So that's also incorrect, but it could be both lowercase r because we are homozygous for seed shape. I can see that 2, 4, and 7 are correct independently. So my answer is D. Question 18. So when I see titration calculations, immediately I'm thinking N equals CV. Moles, N, is concentration times volume. And I know my concentration or my volume needs to be in decimeters cubed. So I'm going to look for the information that I've got. I've been told that 10 centimeters cubed of 0.05 molar potassium manganate reacts. So I'm going to find out the moles of potassium manganate. So my moles of my potassium manganate, I use a little symbol so I know what I'm talking about, is going to be concentration times volume. So my concentration was 0.05. It's given to me here. And then I'm going to need my volume, but I need to convert that into decimeters cubed. So I need to divide it by 1,000. So times 10 divided by 1,000. And when you get used to this practice, you start doing it in your head. So my moles is 0.0005, or 5 times 10 to the minus 4. I then need to have a look at my stoichiometric ratios in my equation. I can see that I've got a 1 to 5 ratio. So then I need to have a look at the stoichiometric ratio in my equation. So I can see that I've got a 1 to 5 ratio of my manganese to my iron. So 1 mole of manganese requires 5 moles of iron ions to react in this equation. Therefore, if I've got this many moles of my manganese, I need 5 times that amount of my iron. So my moles of Fe2 plus is going to be 5 times that, so 0.0025. So now I've got my moles of my iron and I've been given my volume of my iron in the question, so I can work out the concentration. So N equals CV. If I rearrange that, C, concentration, is equal to moles divided by volume. So my concentration is going to be my moles of my ions divided by my volume. And my volume is 25 centimeters cubed divided by 1,000 to convert it into my decimeters cubed. And that is equal to 0.1, or 1 times 10 to the minus 1 moles per decimeter cubed. So my answer is E. Question 19. This question states that the expansion has caused a change in the electromagnetic radiation from gamma rays to microwaves. And we know from our knowledge of EM waves that microwaves have a longer wavelength and a lower frequency than gamma rays. So immediately I know that statements 1 and 2 are incorrect. Now statement 3 is always going to be incorrect because wavelength and frequency are always inversely proportional to each other. Therefore, which of these statements are correct? The answer is A, none of them. Question 20. With probability questions like this, it's always a good idea to draw a quick tree diagram. So we've got Sylvie. The probability that bus is on time is 0.6. So 0.6 bus on time. That means we've got a 0.4% chance of it being late. Now, if the bus is on time, the probability that she will catch the train is 0.8. So catch train. That means misses train. The probability is 0.2. Now, if the bus is late, the probability that she'll catch the train is 0.6, because it tells me that. And then, therefore, it must be a 0.4 chance that she misses the train. You don't have to write it all out in order to save time in the actual paper. The question contains the words given that, so we need to recall our given that formula. So our probability of B happening given event A is equal to our formula, the probability of A and B, divided by the probability of A. In this case, event A is Sylvie catching the train, and a given event B is the bus being on time. So P is bus on time, given that she catches train. So that is equal to 0.6 times 0.8, 0.6 times 0.8, divided by 0.6 times 0.8 plus 0.4 times 0.6. So if I simplify that, that is equal to 0.48 divided by 0.48 plus 0.24. And so, again, simplify that further, I'll take it over here, is 0.48 divided by 0.72. And finally, I'll notice that these are divisible by common numbers, so they're both divisible by 24. If I divide both sides by 24, I get 2/3. So my answer is E. For this first question, remember that 3 base pairs codes for 1 amino acid. Therefore, if we've got 500 base pairs, 500 divided by 3 means we can get a maximum, I agree, of 166 amino acids. So that statement is correct. Our second statement, a liver cell and mature red blood cells from the same person will have the same chromosome number. Mature red blood cells do not have a nucleus, so we won't have any chromosomes there. And finally, the number of adenine bases in an allele must be the same as the number of guanine. Remember, adenine is complementary with thymine. Guanine is complementary with cytosine. So this statement is incorrect. The adenine base in the allele will be the same number as thymine bases, not guanine. So we can see that statement 1 is correct. So my answer is B. Question 22. Here I've been told that I've got a straight chain alkane. Okay, so I'm going to write my general formula, CXH plus 2. It says it's completely combusted, and therefore I know we're going to make carbon dioxide and water. So we're being asked, we've been told that it's going to give off 105 centimetres cubed of carbon dioxide. Due to Avogadro's law, we know that 1 mole of our gas is going to occupy the same volume. So we can see that the carbon dioxide is being produced in a 3-to-1 ratio because there are 3 35s in 105. So I can therefore see only one compound has got carbon in it on this side, and only one compound has got carbon in it on this side. Therefore, for every molecule of alkane that's combusted, we get 3 molecules of carbon dioxide. So we know we're going to have a 3 in front of that number there. Therefore, this number here also needs to be 3. So in order to then balance this equation, it's going to have to be C3H8 using my general formula. Therefore, my answer is going to be D. Question 23. So a really useful formula for this to start off with is remembering that momentum is equal to mass times velocity. And then we can calculate a number and bring it into another equation. So as the question is asking us for the force due to water ejected by the entire jetpack, not just one nozzle. Remember, we've got 2 nozzles. We must calculate a new momentum value for this. So it's generated by both nozzles. Therefore, the mass is now 800 kilograms because we get 400 kilograms from each. So momentum is mass. So from both the nozzles, it's 800 kilograms times the velocity that's given to me, which is 15 meters per second. So that gives me a value of 12,000 kilograms meters per second. Then I need to connect my momentum with my force. So another equation we need. Force is change in momentum divided by time. So the initial momentum we're going to assume to be 0. Therefore, our change in momentum is going to be the full 12,000 kilograms meters per second. So using the formula, the force is therefore going to be my 12,000 divided by time, and it happened over 12 seconds. So my force is going to be 1,000 newtons. Now this question has asked me what is the water ejected by each nozzle. So actually to do this part here, I need to simplify the first equation. So remembering that momentum is mass times velocity, in terms of each nozzle, my momentum is equal to 400 kilograms, just for one nozzle, times the 15. So it equals 6,000 kilograms meters per second. So using those 2 bits of information, we've worked out momentum for each nozzle and we've worked out the force overall. We can see that my answer is A. Question 24. The first thing I need to remember is that the interior angle of a pentagon is 108 degrees. So I'm going to make a note of that at the top. In the diagram below, I'm going to add in my north, and I'm going to show that my bearing is 110 degrees at the start of that third leg. And because I know my internal angle is 108, I can therefore work out this angle in red here. So, of course, that is 360 minus the 110 minus the 108. That tells me that that red angle is 142. Due to the supplementary rules angle, I can then work out what my bearing is on the second leg. So simply, if I put in my north there, the bearing on my second leg will be 180 minus 142 due to that supplementary rule. So that's 38 degrees. So here, and of course, remember, I know that my interior angle is 108 degrees. So I'll put north onto my bearings again. And using the supplementary rules angle again, we can get the angle of 34 degrees for this tiny angle here, which is, of course, in this particular case, 180 minus 38 plus 108, and that is equal to 34. So that's how I got that angle. Finally, I can work out the bearing on the first leg, because I know that this fall angle all the way round is going to be 360 minus that 34 that I just calculated. So that's going to be 326 degrees. Therefore, my answer is H. Question 25. So, in a normal ultrafiltration process, large protein molecules should not be able to pass from the blood into the Bowman's capsule. There is a fine mesh there that's filtering through, and we don't want any large protein molecules. So there should be no protein molecules in that ultrafiltrate at all. If there is protein in the urine, it's suggesting a problem in the ultrafiltration process, but nowhere else will have that issue. So we can see here that statement 1 is correct. There is damage to the cell membranes between the blood vessels and the Bowman's capsule. It's allowing molecules through that should not be allowed through. Now, because I've just stated that this is purely an ultrafiltration issue, it's not going to be related to any other aspect. So statements 2 and 3 are incorrect because they relate to other concepts. The reduced rate of active transport in selective reabsorption, that's not to do with filtration of the Bowman's capsule, and statement 3 to do with the collecting duct. Again, not to do with ultrafiltration. Therefore, we can see here that the answer is B, statement 1 only. Question 26. So this one really makes you think. Okay, so we know that diborane with a relative molecular mass of 26 is going to be made up of 2 B10 atoms as well as 6 hydrogen atoms. Okay, so the probability of that molecule being made is going to be 20%, so 0.2 times 20%, because we need 2 of those molecules. So that's going to be equal to 0.04. Now, if we've got an RMM of 27, we've got 2 options here. So it's made up of 1 boron 10 atom and 1 boron 11 atom. There are 2 combinations here that we could have. We could have and so subsequently, our probability is going to be times by 2. So the probability is going to be 2 times 0.2 from the boron 10 times 0.8 from the boron 11. So that gives me 0.32. So I'll underline these probabilities as I calculate them. And then finally, if we've got an RNM of 28, that's going to be made up of 2 boron 11s. So that's going to be 0.8 times 0.8, so that is 0.64. I can then create a ratio using this information. So that is 0.04 to 0.32 to 0.64. And then I can simplify this quite easily to 1 to 8 to 16. Therefore, my answer is E. Question 27. So this question incorporates all of the equations we use in the study of transformers. So the first formula involves the number of turns on the coil and the voltage. So remember, voltage out over voltage in is equal to the coils of the secondary and the turns on the primary. And let's represent the voltage out that we don't know as X. So I'll do it down here. X divided by 240 from the information we're given is equal to 100 over 400. Therefore, I can work out that X is equal to 60 volts. So immediately I can eliminate E, F, G, and H. As the transformer is 100% efficient, we can use another equation. I'll add it up here. Remember, VP IP is equal to VS IS to work out the input current. And again, we'll represent the input current as Y. So using that equation, and I'll carry on down here, 240 times Y, using the information we're given, is equal to 60 times 2. So Y is equal to 0.5 amperes. I can further eliminate C and D. Finally, to work out the output power, we'll use the equation P is equal to IV. So, power, P, is equal to I 2 times my value for V, which is 60, and that is, power is obviously in watts, 120 watts. Therefore, my answer is B.